Hi, welcome to the first of a series of videos on AI/ML on Kubernetes. I'm Tom Corcoran, a solution architect at Red Hat, and I'm joined by Faisal, who will introduce himself now.
Thank you, Tom. I'm a colleague of Tom working in the AI/ML space in Red Hat.
This demonstration features an end-to-end AI/ML workflow that's depicted here on screen and showcases several responsibilities that surround data science that often present challenges to the business. Things like data preparation, sharing and collaboration of data and ML models, DevOps and CI/CD for ML models, in particular, automated deployment of models in a rapid and secure fashion. Also, serving of models in production, allowing client intelligent applications to make RESTful calls to the model for inference, as well as the data science, obviously. Our focus here is addressing challenges that are frequently encountered in AI/ML models so that AI/ML can add value to the business. We're going to run our demos on Red Hat's Enterprise Kubernetes Distribution OpenShift, which will allow this demo to be run anywhere on-prem or on public cloud. The use case involves using AI/ML to predict customer churn or the likelihood of a customer leaving us for one of our competitors. And we're going to break this workflow demonstration down into a series of videos and make them available here on YouTube. So now we're going to briefly walk you through the demo at a high level, and I'll hand you to Faisal to start that.
Thank you, Tom. As Tom has mentioned, we are focusing on making sure that the model is useful for the business. And the model development lifecycle is basically a 4-step process. The first step is you got to understand what kind of data is required and where you are going to get this data from. It can be structured, non-structured, streams, file, and you need to process that data so it can be used for the modeling bit. The first step is data engineer persona that will help fetch the data from multiple sources and help you bring it to a form that can be useful for the data scientist. And we'll be showcasing Apache Spark doing so at scale. Once the data is available by the data engineer, they will store the data in an object store so that data scientists can access that data at their own pace. And what data scientists will do is use the data to do exploratory analysis, like, for example, visualizing the data set, see if you have a right amount of variance in the data, and there is not bias against a certain parameter. This is an iterative process, and if the data scientist needs some more data, they will communicate with data engineer, and then they will find out more sources or more field in the existing data set to make sure that the focus is kept on the metric they want to achieve. After that, after visualizing and understanding the data scientists need to experiment with different combinations of different models. For example, decision tree classifier or random forest classifier. And within each model, they need to focus on multiple parameters and see which parameters is actually the right fit. It's giving you the right metric. It's giving you the right outcome that is business is expecting from this particular model. So for that, he or she, the data scientist, will run lots of experiments with a lot of combinations. And they want to compare what they have done in each run. So for this, we are using Verta.ai as a model tracking database, which will help you store all the hyperparameter, all the model parameters, and the metric achieved for each run. For that, and then data scientists can compare multiple combinations, and they not only can compare, but also share the experiment with the other team members in the organization. So that will help spread the learning with the individual data set. Once the data scientist is happy that the model is performing as per the metric adjusted, they will, the next step is to basically take this model and take it to production. So I'll give Tom to talk about what happens next.
Thanks, Faisal. So next, the data scientist checks their code and their model into source control, which triggers a CI/CD pipeline flow implemented by Jenkins, as you can see here on the center right, which downloads the model, builds and packages a container from the model, and then deploys that model into production in a secure and a rapid fashion. The fourth stage, slightly to the right, involves a runtime model serving component called Seldon, which is used for inference by intelligent applications. Seldon allows and exposes RESTful API calls to be made by these client applications, so they can make an assessment on how likely this customer is to churn, from which the correct action to prevent that can be taken. As this Seldon model serving component is also running on Kubernetes, it can auto scale in response to high demand and back down again when demand dies away, saving valuable infrastructure costs. Finally, this Seldon model serving component exposes various metrics on the model performance at runtime, allowing us to use Grafana for visualization of those metrics in production, as you can see on the right. So as we say, we'll be making these videos of these subcomponents of the workflow available here on YouTube, as well as the source code on GitHub. So you can use it as a basis for your own AI/ML workflows and work, build on our work, allowing you to address many of the challenges, the business challenges in an AI/ML workflow. So that's it from us. Thanks for watching.